Dealing with warp lead frames is costly in the sense that sometimes when you have automated systems, they need to pick the lead frames and move them around. And if these systems, these machines, they're not well designed, sometimes they can mispick or they can push and they crumble up all the frames. That means that the frame now is broken. You cannot use it and you have to throw away all the parts on it basically. So you take the frame, you throw it out. It boils down to the automation that you choose more rather than the plasma process, for example, that you choose. You need to have an automation system that is reliable enough and has a wide enough capability to treat the standard frames and also the one that have some warp or that are not completely flat. It's an automation problem to solve rather than a process problem. Instead of having something flat, you have something that is maybe too heavy and so it sags down like this and so you cannot pick it. It's more like a transfer, like a problem where you have a mechanical interface that doesn't fit. Sometimes, depending on the number of things that you have to mount on a frame and the fact that frames are thinner and thinner, they can be a little bit harder to pick because they're not well aligned into the magazines. But for that, you have engineering solutions. You have things that you can do in the automation cycle to be sure that you're always picking in the same position. And even if there is some variability, you have the tools to account for that. The lead frame stays into magazines and sometimes the pitch is a couple of millimeters between one and the next one. And so you have to imagine that you have to go in and pick between -1 millimeter +1 or something like that. But if the frame is sagging, you may miss that. Either you need, there are different solutions that you can adopt. One thing is the design of the gripper itself. The other is the position, the horizontal position where you pick the frame. We do that for all our customers when there is an issue like that. We design grippers only for them. It's something that can be solved with some engineering work. When something happens in production, the urgency comes to the fact that you need to meet your production quotas. So you need to manufacture parts. Basically, if you don't do that, you're losing money. So the urgency comes from that. The idea is that you must have a plan and you must have something to go to. Sometimes you cannot solve the issue immediately. And that puts a lot of pressure on you. But the most important thing is to have a plan. Okay, we have this. We know that this is the problem. Here are the steps that we're going to follow to try to solve it. And so one thing is solving the problem and probably trying to mitigate the effects of this issue. So trying to divert some of the productions to other lines, increasing the shifts. So there are things that you can do on a manufacturing level to reduce this impact. Unless the problem is really obvious, okay, we had this thing broke down, we have to replace it. But if it's something new, then yeah, it's definitely a problem-solving process where you go through all the steps of the things that you're doing and trying to figure out, oh, probably this is the culprit. We're going to try to do this test and see if we have different results. So it's an iterative process until you get to the levels that you want.